Okay, welcome to another video. The objective of this short video is to solve one challenging question on integration by substitution. This is from November 11, and it is rather a challenging question because it's phrased very differently. Let's look at the question. It says use the substitution u equals to tan x to show that for n is not equals to minus 1. This is the expression that you need to integrate. Now remember that you can substitute this for tan x, so I'm going to say that this is tan x power n plus 2 plus tan x power n dx. Okay, and this becomes u power n plus 2 plus u power n dx. Now I've done the immediate substitution first, and then I need to differentiate this and say that du over dx is sec square x. So du over sec square x is equals to dx. So du over sec square x. Okay. Now what I must remember is that the identity 1 plus tan square x equals to sec square x will come in handy here. This is un plus 2 plus u power n, and I can write 1 plus tan square x in the denominator. Then I get du over 1 plus u squared. Now here is when things get interesting. I hope everybody understands that I can break these powers up, and then what I can do is I can pull out a u power n common, so that gives me u square plus 1 here as well. What this does is it helps me cancel this out, and I get u power n du. Okay, I haven't changed the limit, so let's do that too. 0 and pi over 4, so 0 and 0 is 0. Tan pi over 4 is 1. So then I integrate, I say that u n plus 1 over n plus 1, limits are 0 to 1. These are limits for u. So you substitute, you write 1 power n plus 1 over n plus 1 minus 0 power n plus 1 over n plus 1. Now anything to the power of 1 is 1. So that gives me 1 over n plus 1 as my final answer, and that is what I was asking you to prove. That is, hence find the exact value of this dx. Now this doesn't resemble this at all, but let's change sec square x and see if we can come up with something that helps me solve. Okay, so the idea in part B is to that's 2 part A, sorry, that's right, 2 part A. Okay, sec power 4x minus sec square x. What I immediately see is there is a substitute, a common that I could pull out, and I could say that sec square x is 1 sec square x minus 1. Or I could, since I just need a plus, and let's just keep it as a plus. In fact, this would be better. Let's just keep it that. Okay, sec square x is 1 plus tan square x, and 1 plus tan square x minus 1. So that gives me tan 1 plus tan square x into tan square x. And when I multiply this through and I rearrange it a little, I get 10 power 4x plus tan square x. Does this situation resemble the one that I have in the question? Let's try to compare. This one says tan n plus 2. Let me write down the situation here. And plus tan square x. So my situation resembles exactly that. I have tan power nx. Okay, I have the same pattern of powers where I can see that if I keep n as 2, this becomes 2 plus 2, which is 4, which means that in my integral the value of n is 2. I know that if that integral came out to be 1 over n plus 1, then this integral should come out to be 1 over 2 plus 1, which is 1 over 3. I hope that's the correct answer. Yes, that is indeed the correct answer. Then going on to the next question, this is tan power 9x plus 5 tan power 7x plus 5. This again, I see these patterns in powers of 2, but the problem is that I have a 5 here, which is problematic. So what I can do in order to sort of generate that situation, let me just first write that down because it's a long solution. So tan power 9x plus 5 tan power 7x plus 5 tan power 5x plus tan power 3x, and it's integrated from 0 to pi over 4 like before. Now if I could generate the same situation that I had in the previous part where my powers were differing by 2, I could use that initial result to come up with that answer. So tan power 9x, what if I were to break this into two uh, terms and say that 5 is made up of 4 plus 1. Similarly, this could break up into 4 tan power 5x plus tan power 5x, and in the end I have tan power 3x. So I get this as one of the setups that I needed. This is n and this is n plus 2. So I have my answer. 1 over 7 plus 1 is the integration of this part. Then if I look at this, if I pull out the 4 common, I have tan power 7x plus tan power 5x. Again, I have these terms in this format where I can say that n is 5 and n plus 2 is 7. Therefore, this should come out to be 4 into 1 over 5 plus 1 because n is 5. And here n is 3. So this could come out to be 1 over 3 plus 1. Okay. 1 over 3 plus 1 gives me 4. So I have 1 over 8 plus 4 over 6 plus 1 over 4. Adding all of these up gives me 25 over 24. Let's check if that is the right answer. Yes, that is indeed the right answer.